Therefore, back to the example which I quoted a couple of times in the previous sharing on the use of postage. So if you want to send a letter, all right, you write your letter, you put it inside an envelope, you post it into the post office box. After that, who will come? Postman will collect. They will go to their sorting facility centers, check your address and so on. Eventually, put into, of course, pardon me, I'm not using the letterbox. I should have taken a picture of the void deck letterbox to really mimic how it would land to the recipient side. But you get the point, right? The protocol of how you write your letter, of course, the content is for the recipient, just like the way we write the API URL for ThinkSpeed. So on top, this green arrow shows the content for your recipient, but the red arrow shows the protocol for the post office, which means, firstly, you must have a stamp. If you don't have a stamp, you're in trouble, all right? Because the post office will check that, oh, you have not paid for the service. Secondly, your address, your destination address, is it properly written? If it's not, again, it will be gen out at the facility and so on. So these are the different contexts of information that you are putting when you are trying to send a letter using a postage service to a friend or to a company. And therefore, you are hearing this many times already. Protocols is really about transferring of information. Right? It could be one-to-many, means that you are sending from one side, from your end to many of your friends. One example would be a WhatsApp group chat. Or when I make an announcement in our course website, it's one-to-many because I put in a notice, all the students get to see. Or many-to-one, which means if you are a gateway, many sensors come to the gateway, then this is many-to-one. It can be many-to-many, all right? So depending on your use case, it could be one of these. Protocol must be able to listen to events, something that you have learned before, like interrupts. I have talked about events with button press, with the use of a mobile application and so on. After having all this notification or events kicking in, your system must be able to react, all right? Must be able to react. Small payloads. So here, when we send information into the internet, we don't really send a very big crates of items. We chop things down, all right, and put them into small packets. And this is where the payload comes about, because we are trying to meet that requirement. Even when you watch YouTube, it is not sending over the whole video file as one, but instead it's streaming. All right, the word streaming means that it is going along with small packets of data, just like water flows along a stream, water flows along a river, the water molecule are being transported downstream, and that's where, when you receive, they are all in small packets. Why do we want it to have small packets? So that it's easier to be maintained and operated over low bandwidth network, right? Some network are not supportive of high data rate. Therefore, we want a protocol to be versatile so that we can work on some of these things. Power constraint. Earlier, we talked about application. Depending on your use case, if it's a sensor, definitely it should be on the side of a lower power requirement. Sensors don't use up a lot of energy. However, if you have devices, or in this case, smart actuators with motors or with heaters, these are energy hungry components, and therefore you got to be mindful on how to work on them. About security, all right, then protocols must be able to support authentication during the transport layer, right? Subsequently, real time, all right, here we talk about how fast you can send your data. And of course, in today's context, you can see, just like now, doing a online lecture with all of you, this is where it is close or almost real time. The delay is almost unfelt. Unlike 10, 20 years ago, when we do a video conferencing, especially if you are doing a trunk call overseas, you'll find that you will still experience maybe a second or so, kind of a delay. When you say, hello, how are you? You have to wait for 1 second or more before your friends or relative over the other side of the phone will respond to you. This is because of the transportation delay, right? But nowadays, with all the high-speed infrastructure network that we have, the internet now is very, very fast. Last but not least, guarantee of message delivered. Here, TCP/IP guarantee, all right? I say again, for internet protocol, it has a guarantee message delivery. What it means is that even if it's not able to deliver, it will continue to try and to make sure that it will deliver to the recipient side. But of course, if you send a wrong address, then this part will be an endless loop. Now, this is a picture to just showcase the different facets that I've discussed before. The smart devices on the left, right? Coming to the gateway, which I mentioned to you. The protocol between the gateway and our smart devices must tally, all right? They must tally. So in this case, if it's ZigBee, then your gateway must support ZigBee. So once your gateway gather the data, the gateway can have a few options to connect to the internet by Ethernet cable, by Wi-Fi, all right? And once it's getting into the internet, very likely it will make use of TCP as a means to exchange data as the transport. But when we talk about application level, then here we can look at either MQTT or HTTP. Okay, I want to pause here for a while and highlight these two. All right, HTTP and TCP, they are at a different layer or level. TCP is responsible for transport, all right? Just like our Modbus, remember our Modbus data frame? Our Modbus data frame, that format of how you put in the data frame may include the address, all right? This is for the purpose of transport. Why the address is important? So that the Modbus data or data frame, when it's transported through all the Modbus devices, the server will know that it has been called. So similarly, in TCP IP, which is at the transport layer, we are needing to provide the IP address of the destination. However, most of the time, we don't use IP address per se. Instead, we use domain name. Like, for example, www.google.com, this is domain name. ThinkSpeed, api.thinkspeed.com, this is again domain name, which is tied to the server that we want to go to. And how does the transport layer know where is it? Because there is a server responsible to convert domain name to respective IP address. All right, so this part just for info, so that you are aware that TCP refers to the transport. But when we use the URL, we are actually coming up to this HTTP application layer, because at HTTP, it is a format that we are using to display within a web browser, right? So this is the application side to present your data, present your chart, and so on. And this is how you can view information from ThinkSpeed website. Okay. Now, so coming back to the internet, this is where after you have joined the internet, when your information after being transported, it will land onto your destination, be it your storage, be it for data analytics, or eventually back onto your devices, right? So this is just a highlight on the different use case and the different terms and names used in IoT architecture. Right, for those who don't quite understand what TCP or UDP is about, you can watch this video. In short, TCP is the guaranteed delivery that I've mentioned before. UDP, user-defined datagram protocol. UDP is a less stringent one, but because it's less stringent, it lacks that guarantee, right? So again, I don't want to dwell too much. For those who are keen, or some of you might be again scratching your head, so what are all these things? You can watch this YouTube or read out this link where they give you information. And I think the video provides or use layman descriptors to describe what this is all about, so that you can gain better understanding. And therefore, if you are developing a local area network for communication, for IoT, or etc., then you are given that choice of using TCP or UDP, and NKR can be deployed to do this too also. Now, this is where I want to highlight to you. Remember, when we talk about Modbus, or when we have a lecture on Fieldbus, we are actually at the physical layer, all right? So the physical layer is referring to RS485. RS485 refers to our physical connection layer. But when we talk about Modbus, Modbus will be an application layer. Now, I want to introduce MQTT to you, which is one of the most commonly used protocol in today's context. And of course, not that there are no other choices, just that most of the users and developer uses MQTT. There are others like OAC and so on, all right, which I'll describe. in the next few slides. So back to the layer definition, I have described to you that the physical layer talk about how things are connected. All right, network layer talk about the transmission technologies, how message is being transmitted. And this is where our IPv4 and so on to define how addresses are formatted. And then finally on the transport layer, which I described to you, where they will then physically route you through that network to the final destination. And end of the day, all right, when the packet reaches the destination, then this would be the application layer to unpack the packet and to look into what are the data sending by the or what has been sent over from the sender. Just to give you an example, here we are talking about a smart, okay, I won't use smart here, a webcam. All right, so we just talk about a webcam. A webcam captures images or video, and it provides streams or streaming to wherever your monitoring center is. So for example, if you are putting a webcam at home and you want to monitor security at home, you can then use your laptop, PC, or your handphone to observe what is going on at home, right? So what has been used? TCP, all right, will be that part to communicate to your webcam if you are remotely located. And this is the port 80 that is used to connect to your webcam. So what is required of your laptop or handphone is that it must first initialize. Remember, server client, which we learned about previously. Client is your customer. They'll go to the restaurant, right? So here, your client must initiate the TCP to the server. So who is the server? The webcam, right? The webcam is providing a service to provide the video. So after initialization, the server will then respond to accept the connection. After connection, here, these are all the small packets of data where the HTTP messages, the messages will be packets of streaming images or video that will then continue to be streamed to the client side. And when everything is done up, we can close the connection. So the connection must be closed so that we can end off all these facilities and services. If you don't close, sometimes you may bog down the network because it is still thinking that you are there, all right? And the camera or the webcam is still streaming and causing a lot of unnecessary jam up. However, the internet is still quite smart, all right? When they realize that there has been a disconnection of a device within the internet, this will actually stop any of the streaming. So why is this not so good? Because as I mentioned before, TCP guarantees the delivery and is using a lot more power, a lot more resources. Therefore, it has high overhead. And you see earlier that there are the requests or the initialization phase. You must first initialize. You must be the initialization will then follow up with a request, with an acknowledgement, and then the actual data exchange happens. And this is where the use of TCP and HTTP doesn't support very simple protocol. There are a lot of things that happen behind the scene, and there are pre-information. I don't know whether there's such a word called pre-information. What I'm trying to say here, the bulky header, just like our Arduino code, you have header, right? To put in the library as addition of libraries, so on and so forth. This bulky header is to describe the needs of your data transfer. And this bulky header sometimes are non-essential and they are not critical to your data, right? However, since we are using TCP, TCP/IP protocol, we have no choice but to also add in headers just to support and to align with those requirements, right? Finally, constant polling of data required for update. What does this mean? You have learned from Prof. Howard about polling and interrupt. In order to know what is going on, you have to frequently request for new updates. And this is going to be quite wasteful in resources, especially where cases where there's no new update or new data, but when you constantly poll for information, you are receiving the same old data. So this part, this is something that's not so nice. So opposing to continuous polling in the internet context, what we have is the use of notification, right? For notification, all right, this part is not what we are teaching in this course, but for MQTT, probably I will share with you how MQTT can provide that kind of instantaneous notification. So back to connectivity, all right, we have talked about the protocol, so that devices speaking the same language can communicate. And these are the various protocol in IoT ecosystem, like the DDS, Data Distribution Service. Okay, don't have to worry about the full name and so on. I'm just sharing with you some examples. AMQP, these are Advanced Messaging Queuing Protocol. We have COAC, all right, Constraint Application Protocol. What I need you to pay attention to is this one with the asterisk, because you are going to learn about this in depth. You are going to make use of this in our lessons. And this is the MQTT. What is MQTT? It refers to Message Queue Telemetry Transport, right? So we are taking the first letter of these four words, Message Queue Telemetry Transport, and there we have MQTT. What is it? It is a lightweight messaging protocol built on top of TCP/IP, right? We are still using TCP/IP, but we can truncate some of the unnecessary heavyweight component and yet being able to send data over, right? So at application level, MQTT helps to reduce the resource, and I want to give you some insights to why MQTT, because with MQTT, we are able to overcome the 15-second problem. Some of you, if you are not aware of the 15-second problem that I talk about, revisit week 6. Week 6, when we deal with ThinkSpeed, we have the 15-second update constraint. When you use MQTT, it seems to bypass that problem. All right. So do try out during the lab activity.